targeting conservation actions for curlew and other birds. Jenny.
Thanks, David. Follow Mary. Let's have a go. Yeah, thanks ever so much. What I want to talk to you about is some of the work that we've been doing in our research group on this, targeting conservation actions for curlew. As Mary has so clearly laid out, we're going to need actions if we're going to stop the Eurasian curlew going the way of the Sound-about curlew. And a lot of the work what we spend our time thinking in our research group is, okay, but what? What are we actually going to do? And how can we help that process of working out what appropriate actions might be? And of course, they're needed, not just for curlew. Many of our bird populations are declining, and they need conservation actions to halt and reverse those declines. The question we're particularly interested in is, okay, but which actions and where? What can we do to figure out what the appropriate actions should be and where they should be targeted? What do I mean by conservation actions? I mean on the ground things that we do, things that we know can be effective to help populations. We can do loads, right? We can protect important sites, and we do a huge amount of that, identifying important areas, making sure they stay in good condition. We can create new locations with habitat creation. We can manage habitats to make sure they provide the resources that the species in them need. We can provide the resources directly in some cases. We can manage the effects of interactions like predators, and in extreme cases we can bring things into captivity, breed them for translocation and reintroduction. The toolbox is large. There's lots of things that we can do, and we know that these tools can be highly effective. And to give you a quick example of this, this is a species known to many of you. This is the European black-tailed godwit, a species that a population that breeds widely across Europe, and here in the UK, our population dwindled to just 50 pairs in recent years. So a real conservation concern. Some great work by the RSPB, studying and following their nesting attempts over many years, showed us what their productivity was. And you can see, if you look what was happening about a decade or so ago, there was a growing realization that productivity in most years was effectively zero. So not only did we have a tiny remaining population of these birds, but they were going, and they were going fast. We were going to lose this as a breeding species of the UK very fast if we didn't act. Okay, so what are we going to do? Well, first of all, because we need to know why. Why is productivity so very low? So again, intensive field studies were carried out. And what they showed, and this is no surprise to you, is that the problem is at the egg stage, right? The problem is unsustainably high losses of eggs to predators, primarily the red fox. As a consequence of that knowledge, and with EU funding under the LIFE project scheme, the RSPB and Wildlife and Wetland Trust came together under something called Project Godwit, which was designed specifically to deliver actions to help this population. Because the problem was mammalian predators primarily, it involved things like deploying fences, we're going to hear a lot more about that over the next couple of days, to exclude them from places where the birds were breeding, but also head starting, as is now happening with lots of curlews. So bringing the eggs into captivity, raising them, hatching them, raising them through to the point of fledging, and releasing them in the hopes that they will survive, come back and breed successfully in the future. And in the case of Project Godwit, this has been a huge success. More than 200 head-started godwits released since 2017, and we're already seeing increases in the breeding population. So targeted conservation actions work. They really can work. And they're relatively easy to do for something like the black-tailed godwit, whose distribution had already got to the point where I would describe them as very much rare and localized. They only persisted in a very small number of sites. This is a BTO map. It's actually, the situation was more dire than this. They were essentially here. That was it, in the washes, in the Ouse and the Nene washes. So the question of where action should be carried out is pretty straightforward, right? We've only got a couple of sites left where they exist. And the question of what should be done could be answered by intensive studies at that small number of remaining sites. Curlew presents us with a different problem, right? Because they are, as many of our bird populations are, widespread and declining almost everywhere. So this presents a very different challenge. How do we work out what sorts of actions are going to be needed and where if we're going to help recover these species? This is the question that we spend quite a lot of our time thinking about and trying to work out if we can if we can help in sort of that process. So can we target actions to recover widespread declining species? Now, a lot of the work that on this has been done in relation to curlew, primarily through someone who you'd be quite familiar with, sitting in the audience here, Harry Ewing, who I had the great privilege of supervising Harry's PhD working on breeding curlew in collaboration with BTO. Harry was working in the Brex, and I'm sure lots of you have heard about his work over the years. So Harry was interested in this specific question: how would we go about targeting the types of actions I've described for you to help something like breeding curlew? And it helps to think, well, what's the goal of the action? What's the ultimate goal? And the ultimate goal is to boost demographic success. If you're trying to increase numbers of a population, you're trying to do one of two things. You're either trying to create more of them, so you're trying to boost productivity, or you're trying to help them live longer so that they themselves can boost productivity. Ultimately, that's what a conservation action is about. It's about intervening to try and influence a demographic rate, productivity or survival. In Harry's case, we're particularly focused on productivity for reasons that Mary's already outlined. That's where the problem lies. And so Harry thought about it like this, was to say, well, okay, what about if your productivity differs, if it varies across your population, if it's sometimes low and it's sometimes high? That knowledge can help us to understand what we should be doing, particularly if you understand how high and low productivity is distributed across your population. So where the numbers of birds are experiencing different demographic rates. Let me talk through what I mean by this. Imagine a situation in which productivity of your population is high and the conditions supporting that high productivity still support quite a lot of birds. If that was the case, if you had lots of birds experiencing high productivity, you want to protect that, right? That's a clear goal for protection. Things are going well and there's still quite a lot of birds supported in those conditions. So very clearly protect that. But if, as is much more often the case, productivity is low and the conditions in which productivity is low support lots of birds, well, you definitely want to protect it, right? Because there's still a lot of birds there. But protection alone will not be sufficient because you're just going to be watching them go locally extinct. So you need actions to improve productivity as well. So targeting here would be about protect them and do something to improve productivity. If you had a circumstance in which productivity was high, but those conditions supported relatively few birds, protect because it's working, and maybe this is a good case for create more. Whatever it is that you've got there is working, so find a way to create more of that. And finally, if your productivity is low and there's not many individuals experiencing this, well, initially Harry and I had give up in this board, but we decided that's a little bit negative. So maybe this is a case for improve, but probably as a relatively low priority. And Harry in the Brex had two examples of these for them, because if you know the Brex system, you'll know that the great majority of curlew they are breeding grassland. And Harry's research had shown that productivity there is persistently very low. So this is very much a case of this top left box here. Most of the remaining curlew, the Brex are in the grassland. We have to protect those curlews, but protection alone will not be sufficient. We're going to need to act to boost their productivity. And that's exactly what BTO and Natural and lots of people in this room have been involved in over the last couple of years, is trying to boost their productivity with fences and so on. In the Brex there is, however, a relatively small number of curlew that breed on arable fields, often around the edge of those big grassland populations that they occur in. And here, Harry was able to show their productivity is actually a bit higher. So they probably sit more in this sort of box here. There's not many of them, but something is whatever's working is working a little bit better there. So this might be a case of protect what you've got and create more. I would say this is a classic case for targeted deployment of an agri-environment scheme to make sure that the conditions providing curlew with good breeding conditions are available in the landscape around those big grassland patches. So this is how this framework could potentially be used to help guide the types of actions that might be appropriate in particular locations. And it relies on us knowing how the abundance of our species and their demographic rates, in this case productivity, are distributed across the population. We need to know where they are and how well they're doing in different parts of the range. And we know that because of citizen science, because of people like yourselves, right? It's absolutely crucial in them providing this sort of information. And this is kind of the theme I want. Take away one thing from all of this, is that we absolutely need citizen science information if we're going to do anything in conservation. So these sorts of surveys are terribly important. And it's also really important that citizen science surveys go on in the long term. It's important that this isn't just one-off, that we keep doing this over long periods. And that's because if you're trying to boost the demographic rate and trying to understand how it's distributed, the problem with things like productivity and survival is they could vary between sites, but they can also vary in time. They can vary between years. And some brilliant work by one of my colleagues, Kat Morrison at UEA. Kat's looked at this in detail and tried to understand, okay, if your demographic rates vary between sites or between years, what does it mean for the types of actions that you might want to use? So thinking about it again like this, the demographic rate you're interested in, let's call it productivity, might vary spatially, so that you've got consistently good sites and consistently poor sites, like Harry's Curlew. But it might also vary between years, so that you've got good years and bad years. What types of actions would you do in those circumstances? If you've got a situation where you've got the variation in your demographic rate is spatial, so you've got some sites that are consistently poor and some sites that are consistently good, then it's relatively straightforward. You want actions in your poor sites to make them good. You target it like that. You know the conditions associated with poor productivity, target action there to make it better. So we might be talking about things like habitat improvement, resource provision, predator management through fencing, that sort of thing. So relatively easy to do in that circumstance. But if your demographic rate varies in time, so if you've got what you've got is a lot of good years and bad years, and especially if you don't know where those good years and bad years are going to play out in space, then maybe what you need to be doing is deploying actions to help those bad years. So you might be thinking about things like temporary actions to reduce the effects of bad years, to help things recover from bad years and so on. So understanding how your demographic rates is important both spatially, but also how it varies in time. And Kat's been doing a lot of work on this using, again, citizen science data. She's been working a lot with particularly Euro CS data. So you might have come across this, any of the ringers in the audience. This is CS is the constant effort monitoring scheme. These are cases where people go out and catch misnet landbirds, and they do so in a highly standardized way. It's constant effort monitoring, which means ringers put exactly the same nets in exactly the same places at exactly the same times every year. So highly standardized catching of landbirds, of passerine birds. And because it's so highly standardized, it means you can measure things like productivity, which in the case of CS data we measure as the number of juveniles per adult. So you can imagine calculating for every site across Europe, and there's hundreds of them, productivity at that site every year. And because we ring the adults and then catch them when they come back, you can also measure their survival rates, how many of them come back. So again, you can get how much the survival rates differ between sites and between years. And when Kat put all of those data together to ask how much do the productivity and survival vary between years, how much is it good, bad years, and how much is the variation between sites, good sites, bad sites, it turns out, and this is for passerine landbirds across Europe, it turns out that productivity is consistently in the spatial box. So across Europe, we do have sites where productivity of landbirds is consistently low and sites where it's consistently high. But once you turn to survival and looked at survival rates, now that much more annual variation there. So it's much more the case that you get good years and bad years. So again, this sort of understanding can help us to work out what we're trying to do. A lot of these populations are in decline, and we're going to need to target actions to do something about that. I think what this is telling us is that productivity is going to need action in poor sites. Survival will need action for poor years. What does that mean in real terms? I think what it means for European landbirds is that what we should be trying to work out to do is target actions to boost productivity in places where it's low. And what we're trying to do at the moment is work out what are the characteristics of sites where productivity is low for these sorts of birds. Looks like it's linked to invertebrates, but that's a story for another day. But importantly, you can't ignore survival, right? Because you could do all this work and boost productivity. But if climate change means we get our whole run of bad years, which means their survival rates are really low, it could wipe out the benefit of all of that. So we're going to need something to make sure that they survive to come back and breed successfully as well. But it varies annually. It differs between years in different sites. So how do you target actions to help there? We've scratched our head a lot about this one, and I think the solution is this. We're going to need, in addition to targeted action, we're going to need widespread action to protect, improve and create habitats right across the ranges of these species. Essentially give them options. Give opportunities to make it through the tough years when they come, so they can come back and get the benefits that we experience from targeting actions in the breeding season. So again, a framework for the types of actions and how we might go about targeting them. So, and citizen science data, right? So citizen science data can really help us to identify demographic targets. So should we be trying to boost productivity or survival? Spatial and temporal, where and when should we be carrying out these actions? And relevant actions, what types of actions should we do? So all of this, I think, is really, it's possible to do all of this, to work out what we should be doing where. In locations where the species of interest still occurs. So when they're still there, we can try to intervene and do something about it. But we are increasingly, of course, losing things from parts of the range. And increasingly the problem is going to become, can we encourage them to colonise or recolonise unoccupied areas? So another question we think a lot about is, what would we need to know if we were going to try and do that? What's the important information that we might need? And I think the really important stuff here is that we need to know a lot about how individuals go about choosing, if you like, a breeding and a wintering site. How do they end up where they do? Are there rules to this that if we knew, we could perhaps exploit to help us work out how we should encourage them into colonisation? And that's a question we've been addressing for a very long time with the living species here. This is the Icelandic black-tailed godwit. So this is a population of waders that breeds almost entirely in Iceland, in the red there, and winters all around the coast of northwest Europe. And for about 30 years now, we've been trying to figure out the answer to that question, and we've been doing it with unique combinations of coloured leg rings. So catching them, giving them unique combinations, and then trying to read them in the field so that we can track them throughout tracking individuals across the migratory range. So that was the kind of vision at the start of this whole project. Could we mark these birds, send them out there, and then hope that we could track enough of them that we can understand how they move and how they make their decisions about where they go? It's a kind of a crazy idea to imagine you could track the whole population, but we gave it a go, and we were helped by a couple of things. One is, there are not that many of them, about 50,000, and that means that we try to maintain about 1 to 2% of them individually marked at any point in time to give us enough data to work with again. Keep saying we here. It's a huge project, as you can imagine. These are some of our main catching sites, and these are some of the main characters involved. It's a huge international project, lots of us involved in catching these birds. We do the catching, the marking, we try to do some of the reciting, but most of the data come from people like yourselves. In the case of the Godwits, we like to call this our Godwiteers, people that will go out and send us colouring sightings and report the birds back to us. And if you want to know any more about this, this is a link from one of Graham's blogs. So Graham Apton now writes these brilliant blogs on wader research, wader tales are called. So have a look there if you want to read any more about any of this. So what we've been doing is marking these birds and then capturing observations of them. And this little graphic here is essentially our database that you're seeing there. Every dot there is a sighting of birds, the colour is its age, and there's rotating between months, so the lines are just when a bird moves within a month. And you can see the seasonal pattern of movement that we're able to capture as these birds move between their breeding and wintering grounds. Importantly, these colourings are lifelong. right? So we're able to track these birds throughout their lives. And their lives are long. This bird here was one that arranged in 1995. When it was seen in 2015, age 22, the observer was only 15. So they live a long, long time. In fact, they're older than some of the people who reported them. We're going to break 30 years this year. So they live a long, long time. And the colourings are there for their whole lives. And people are sending a sighting. That's really important because there's lifelong tracking, gives us an opportunity to work out where individuals go in wintertime, where they go when they return to breed, and how consistently they do that throughout their lives. Answering those questions that I hope can help us to work out what we need to do if we're going to encourage colonisation. A couple of questions, key questions that come out of it. One, how far do individuals settle from their natal site, from the site where they were hatched? This is a really big question in the moment, particularly with regards to head starting and releasing head started birds. Where do we expect them to go to breed? Turns out, big difference between the sexes here. So these are all the data that we have for Icelandic godwits, for their birds that we've found as chicks that have gone back to breed. When they come back to Iceland to breed, where do they go? From males, they come back to where they were hatched. So we have a mean of about 2 kilometres distance from hatch site to breeding site. Our closest one is a few hundred metres away, the furthest away only 7 kilometres. So the males come back to where they were hatched to breed very, very locally. So the rule base there seems to be, go back to where you know. And then in evolutionary terms, this makes quite a lot of sense to me because this is going to mean that you're going to end up as a male breeding quite close to probably your dad, your uncle, your granddad, and long-lived species. Perhaps this just makes our life a little bit easier when you're trying to squeeze in and get yourself a bit of a land to breed up. Different for females though. Females travel, the distance from between where they're hatched and where they end up breeding is much bigger. It can be the same. We have one bird that's within 1 kilometre, but most of them are way further than that, some of them on the other side of Iceland. On average 50 kilometres between hatching and breeding. So they're following a different rule base, right? The rule base from females doesn't come back to where you're hatched. For females, probably what's going on here is they're trying to find an available male, right? If you're going to find an available male, what should you do? Probably you need to go where there's lots of birds. So this, I think, is important knowledge that we can use to help us work out where we should be targeting actions if we're trying to encourage them to colonise sites. Males are going to go back to where they're hatched. Females, I think, are going to go try to find males. We can also say something about how consistently they do. So, okay, that's fine for when they first go back, but do they always do that? Do they change during their lives? How much does everything change? And I'm just going to illustrate this with a couple of graphics from 2 typical birds from the data set. Here you go, this is red, orange, green, white. This is a bird that arranged on the Wash in the autumn of 2002. This bird in the winter time heads west to Ireland. In the spring it heads up to one of the main arrival sites in Iceland, in Hup. Then it goes west to its breeding site and then it comes back in the autumn. That bird's done that every single year for which we've tracked it. Same thing. Here's a different bird. This one also uses the Wash in the autumn, but this one goes to Spain in the winter time, comes back via Portugal and the Netherlands, again via the east of Iceland, but this time on to a breeding site in the south, and then back in the autumn. And a bird that does something different, but this one also does the same thing every single year. I could stand here and show you hundreds of these patterns of godwits doing the same thing throughout their lives. Lifelong, year-round site fidelity is the typical for most of these birds. And that's what's coming out of the Curlew tracking as well, that we're starting to see more and more of as well. Really, really high site fidelity. This is important because it means what happens in the early life is really important because you don't change much after that. So where they settle is terribly, terribly important. So what does all of this mean for Curlews? Targeting conservation actually for Curlews. Well, if we split it up by season, I think if we think about it this way, in the breeding season, what we're trying to do is we're trying to create more good breeding sites, right? That's the goal. How should we do that? Step number 1, protect anywhere that's still got high breeding success. That's incredibly important. We need to find those sites and protect them. There aren't many. Most of them will have low breeding success. So here we need to protect any site with lots of birds and work to improve them. What do I mean by improve them? Well, because the problem is low productivity, improvement typically means predator exclusion, because that's the problem at the moment. Fencing is working obviously incredibly well. But I would say this is a short-term solution. In the longer term, we need to be working towards landscape scale solutions, landscape scale habitat creation that can reduce the impact of predators. And we are nowhere near knowing what that looks like yet. But it has to be our goal to work out what that might look like in the future. And ultimately, of course, creating and improving habitat and releasing Head Start individuals. And I think the rules that we can learn, what we take away from the Godwits is that we're best doing that close to existing populations, because that's likely where the females are going to come back to. Building on existing populations is likely to be a more successful strategy than starting some new populations in the middle of nowhere. But let's not forget the non-breeding season. Survival might not be a problem now, but as Kat's work shows, you have to remember that there can be this big annual variation in survival rate. You have to think a little bit about that. If our goal here is make sure that they're supported through bad years when they come, I think the solution is the same one that we came up with for Kat's work. Widespread action to protect, improve and create habitats for them across ranges. In the case of large waders like Curlew as well, it can also mean managing and reducing hunting pressures where those exist to help things through those bad years. That combination, I think, gives us some hope that we can work out going forward. I just want to finish up with a thanks to fantastic colleagues and the funders for all of the research behind all of this, but really the big thanks is to all of you, because all of this work can only be done because of citizen science data. Structured long-term citizen science data are the only reason we know any of this. So thank you to everybody who's involved in this room, and let's keep going because we need it in the long term. Thank you very much.
Wow, Jenny, that was amazing.